Hi, class. So this is some of the questions that I had gotten um, for uh, for the questions on combining transformations and the inverse. So we'll start with the combining transformation. So let's look at page 39, number 4a. So here's so this is the existing function you have fx. So what I did was I took the coordinates and then here is the coordinates for kx. Okay, so what I've done here, so these are the types of questions where you're given the original function and the transformed function, and you want to figure out what occurred to get one to the other. Okay, so I will give you questions like this on the quiz and the unit test. So the way you go about this is take coordinates from the original function, so in this case fx, and then find the corresponding coordinates to the transformed function, in this case kx. So now the next thing we want to look at is try to figure out what type of transformations have occurred. So for this one, because the two graphs are congruent, which means they're the exact same size, that means there's no stretch that occurred. Okay, so there's no stretch because they're congruent. So now there's a reflection definitely because you can see that they're reverse of each other. And so what we notice is if you look at the x coordinates for the original function and the x coordinates for the transform function, they have opposite signs. So, and because we're talking about the x value, that means the x value had a negative multiplication applied to it. Okay. Now that takes care of the reflection. And then the next thing you look at is how are the x and y values differing. And so if you factor in the reflection, so like for the first one it's -6, the next one then would become negative, would have been -4, then what that's telling you is is +4. So it would have went from -6 to +6, and then from 6 to 4. That tells you that you've decreased the x value by 2. So this is why we're saying it's 2 left. And then if you look at the y values, so let's look at the first coordinate. It went from 4 to 2. The second one went 4 to 2. The third one went -2 to -4. So that means you've decreased it by 2. So the y value has gone down by 2 as well. Okay, so now we can put all three of these things together. And so here's just another example. If we look at that 2, 3 coordinate, you start with 2, 3, and then it becomes -2, 3 because of the reflection. And then you take away 2 from the x, and you take away 2 from the y, and that's where you get -4, 1. So you want to be able to test a point and see that it goes through all the transformations you think are occurring, and just to kind of confirm that. So overall what we have for kx is we've got a negative applied to the x value, the reflection, and then we have a shift of 2 horizontally in the leftward direction, and then a decrease in 2 vertically. Okay, so that's your function, your transformed function. Okay, let's look at the next one, 4b. So same thing. We take the original coordinates, so the same one for fx, and there's the transformed corresponding coordinates. The orientation of the two is the same, so what that tells you is there's no reflection that's occurring. Okay, so we don't have to worry about a negative or anything. Just from visual inspection, you can see that the width of the mx function is half. Okay, so it's been compressed. So what you can do then is you can take all the x values, all these x values, and you can divide them by 2. Okay, and then after you do that, you can see that what's going on here is all the y values are a decrease of 4. So like 6 goes to 4 goes to 0, 4 goes to 0, negative 2 goes to negative 6, 3 goes to negative 1, so they've all decreased by 4. And then you can also see that the x values, so negative 3 to negative 4, negative 1 to negative 2, 0 to negative 1, and 1 to 0, so they've all gone left 1. Okay, so you've got three things going on here. You've got a reduction by a half, you've got going down by 4, and going left by 1. Okay, so these are the pieces you want to try to find, and so this gives you the overall transformed equation for the function. And again, what you can do once you get the equation is you can test it. Okay, so take any of the original coordinates of the original function, apply this new equation to it, and see if it gives you the transformed coordinates. If it doesn't, that means this equation is incorrect. Okay, let's look at another question. Let's look at, this is a good one too, so I'll give you something like this on the quiz. So what you have here is an original coordinate, and then you've got the transformed equation given to you. So first thing you want to do, and this was causing some, I got a lot of these type of questions with this one here. The first thing you want is you don't want anything in front of the x. Okay, so whenever you see this type of thing here, what that means is you have to factor that out, including the negative sign. Okay, so the negative can't be in front of the x. So you want x to be by itself. So we pull out the negative 2/3, and so that keeps x by itself, and then we get 9 here. Okay, so this is x plus 9. So negative 6. If you divide negative 2/3 from it, you get 9. Okay, and then recognize what all these numbers represent from that equation framework. So A is the vertical multiplier, B is the horizontal, H is the horizontal shift, K is the vertical shift. Okay, and so now when you take that point, so negative 12, 18. So it doesn't matter which one of A or B you do first, but do those first before you do H and K. So let's say we take care of the A first. So the A is going to multiply the 18 by negative 2. So that's where you get negative 36. And then that's the first thing done. Now with the B, remember this has to be the reciprocal. So what you're going to do here is you're going to multiply negative 12 by negative 3/2. Okay, so again, that's the reciprocal. Okay, and so that's going to give you 18, so positive because it's got two negatives. And then you can worry about your translation. So what's happening here is you're going left 9, so you take away 9 from 18, so that gives you 9, and then you're going up 4, so you add 4 to negative 36, and so that gives you 9, negative 32. Okay, so that's your transformed coordinate after putting it through that equation. Okay, let's look at page 53 now. So page 53 had to do with the inverse. Okay, so let's look at 9b. So first thing they want you to do is write out the equation for the inverse. So when you write out the equation, what you want to do is you simply want to switch y with x. Okay, so switch those two first, and then after you do that, what you want to do is you want to isolate y. Okay, so you get y equals negative x over 2 plus 2. You can write it that way, or you can write it as y equals 1/2 negative x plus 4. Okay, so that's the same thing. And then you can graph both these. So they're both lines. So you've got, so the first one there, y equals 4 minus 2x. So negative 2 would be your slope, 4 would be your y-intercept, and then the next one there, you got your slope of negative 1/2, and your y-intercept is 2. Okay, so those would be your inverses. Okay, let's look at the next one here, 9D. Now this one's a little bit tricky. So here, the inequality x is less than or equal to 0. So that's basically an inequality only for the original function. Okay, so not for the inverse, but it does it impacts what the inverse is going to be. So same thing here. The original function is given. Let's find the inverse. So switch y and x. Okay, so you switch those. And so when you take a square root, remember it can be plus or minus. And so this is why you get the minus. It's just connected back to it's connected to that restriction here. Now, when you graph the original function, it should be a parabola, but again, because x is less than or equal to 0, then this part here doesn't show up. Okay, so that's why you only see the left side. And then what you're doing is you're taking the inverse of the left side. Okay, and basically what this negative is saying in the equation here is that it's below the x-axis. Okay, and so that's so again the inverse should also be a parabola, but you're ignoring this part because the original function doesn't have that side. Okay, so what you're doing is you're taking the inverse of the only part of the original function that's present. Okay, so had this this restriction not been there, this inequality not been there, then you would have had two full parabolas. So you'd have the one on the top and then the one on the side. Okay, so I just put the dotted line there to indicate that's where it should be, but it's not there because of that restriction. Now, as far as domain and range go, then the domain and range reflect just the part of the graph that's visible. So for the original function, x has to be less than or equal to 0, and y has to be greater than or equal to 2. And then for the inverse, x has to be greater than or equal to 2 because it keeps moving to the right, and the range is less than or equal to 0. Okay, so I'll stop there. So I think we're starting to get a bit of structure, and I think you kind of see what we're doing. So typically, this is how we want to begin class. So just make sure you let me know which questions you'd like me to go over. Okay, and so there'll be a quiz on this stuff at the end of class again today.